While browsing on eBay for RCDs from China, not because I actually need RCDs from China, but I wanted to see what was available and take a look inside them, I came across this really incredibly neat one that's transparent. And this came from a seller called CGL3478 who sell all the Thomson stuff. Now, Thomson, here is the mechanism. The circuit board has nothing in the back of it. There's the mechanism. And when it trips, that little thing just pops up. And it is a magnet, just tripping that again. And that little flag, it won't go back down, allow that to reset until you click that back in. That's quite neat. Let's not zoom out. Let's just stay right here because I am staying in shot. Let's go in further. Very intrigued by this circuitry. Is it a dedicated 3-pin chip that is doing all this? One thing I'm noting here is the way this senses the fault current, the leakage. It's got windings going through this toroidal core, and the current is effectively, say, flowing out through the blue and then back through the red or vice versa. And each of them is wound round in such a way that if the currents are equal, the load is normal, it will cancel any magnetic field out in the toroidal transformer. If there's an imbalance, it will induce magnetic flow in the toroidal transformer, which is picked up by this little sense coil with the 2 white wires here, and triggers the mechanism. This is going to pop to bits. This is spring-loaded. I can feel it already. It's going to go ping. I have a horrible feeling this may not be going back together. Another thing worth noting is that this is not 2 modules wide or 1 module. It's 1.5 modules, quite an odd size. It's nice that they've got a generous spacing inside it though. So I think I need to get this little thing out here. I need to get, oh, there we go, there we go. This is where it really does all ping to bits. This is what I'm looking for, this little circuit board. I think I'm just going to have to pause momentarily and investigate this, so I'll be back in a moment. The deed has been done, it's been reverse engineered, it's all absolutely standard components, literally just a tiny smattering of standard components. It's times like this I love taking cost-optimized Chinese stuff to bits because it's amazing. The circuitry is just frankly amazing. Wait till you see this. So I did the usual technique where I took a photo of the back of the circuit board, flipped it over, faded it out, and just drew the components on. Not many components to be bothered about. The standby current draw of this thing is 0. It's just staggeringly simple in its design. So we've got live and neutral here, and the first thing that's across them is this big green thing. It's a metal oxide varistor. Shall we just, I know, we'll zoom in just a little bit so you can see this if you're on a small portable mobile device. So you've got the metal oxide varistor across that to protect against voltage transients. Then you've got the trip coil here, which has a resistance of 66 ohms. And that's quite low because it's going to get dumped across the mains effectively when this triggers. But that's going to result in a very, very brief but very high current, just enough literally just to snap that plunger in once and trip the mechanism. If the mechanism doesn't trip, then there's going to be trouble. But that's, in most instances, it should automatically trip the mechanism. And if it doesn't, then the circuit will fail. But ultimately, that would have meant that it had failed in the first place, so it's no great deal. It goes through a trip coil, then it goes through a bridge rectifier made from 4 discrete 1N4007 diodes, 1 amp diodes, just conventional ones. That's these 4 diodes here. And then it goes to a thyristor, a super sensitive gate thyristor, an MCR100-8, very common. And after that, it's the sense coil here, which has the phase conductors. I've shown them going through it once, but they actually go through twice for extra oomph. And ultimately, the winding from that's going to pick up the differential current just has a load resistor of 12K, presumably for some sort of calibration level, a 220 nanofarad capacitor to introduce a very slight time delay and to prevent false triggering of this, and a reverse polarity protection diode, so that that will also mean that in the event of fault current flowing, it's not going to probably saturate this core. Could that happen? This core is not suitable for DC faults. Not many RCDs or GFCIs are. But basically speaking, you've got the current flowing out through this wire and coming back through this wire. And if they're balanced, if it's the same amount of current, nothing will be induced in this magnetic core. But if something leaks to ground, so it's coming in through live, some of it's leaking to ground and not all of it's going back, you'll get an imbalance which will create a small voltage here. And after a very tiny delay, it'll trigger this thyristor. The thyristor will turn on, and it latches on, it turns on, and will effectively shunt the supply rails, which will energize the trip coil and then kill the circuit. The test circuit is super simple. It's got this one resistor here, which is 3.3K. All it does is it goes from one side, which is a really common technique, one side of the coil to the other, so that when you press the button, it deliberately leaks current that bypasses the core between live and neutral. And again, the resistor would get very hot very quickly if you held that button and it was energized continually. But what actually happens is that when you press that in, the current that sees a fault current and it trips and it kills the circuit. It's absolutely incredibly simple. The trip times I was getting were well within the standard British requirement, actually. The requirement in Britain is that at normal current, say this is a 30 milliamp RCD, it should trip within 300 milliseconds. That seems quite a long time, because let me assure you that if you get yourself into the situation that current is flowing through your body, 300 milliseconds, even though it's just 1/3 of a second, will feel like a very, very long time. At 5 times that current, it should trip in 40 milliseconds, and that's a sort of minimum time it should trip in. This fulfilled that, even though it was effectively only going to trigger on 1/2 of the wave. I was under the impression it had to trip within half a sine wave, but really they're just saying trip within, best part of a sine wave. And this is just tripping in either less than the half, or on the other opposite polarity, it'll be just over half a sine wave, so it goes into the other polarity. That's very good. That's really, really interesting. I love that circuit because it is so super simple. And the design in here is just chunky. It's because there's no really dense custom circuitry, it's just really neat. That is nice. I wonder if that's what's in the other circuit breaker as well. I may have to take apart some other standard circuit breakers now just to see what they're like, the RCDs, GFCIs. But this is yeah, I like that. That is very, very nice. I'm not going to say that you should rush out and buy these and install them, because unfortunately there's that situation that if there's an accident and they find that you got stuff cheap off eBay without the British or American or German or Australian, European certification, then they're going to start pointing fingers, as they do. But this, I'm guessing, is perfectly acceptable for China, and quite justifiably so. It certainly seems to do the job.